Hello everyone, I am Dr. Shashank Pathak from IIT Mandi, Department of Civil Engineering. As you might have seen in my previous video that I explained about my area of research and expertise, that is in the structural engineering. Today I am thankful to YourPedia that they are showing you the laboratory that IIT Mandi has, especially in the field of structural analysis. So this is one of a kind laboratory. As you can come with me, I will show you. So for example, you can see there are different kind of tabletop models are there. For example, if you take this particular model that you see there, which is a truss model. So most of you might have done a course on structural analysis in which you have analyzed trusses, frames, simple beams. And here at IIT Mandi, we provide the opportunity to the undergraduate students so that they can verify the theoretical learnings that they made during the structural analysis course with the experimental results. And there are other experiments also, for example, this kind of bridge structure and other simple models we study in this particular undergraduate lab, which is very special lab. And I have experience of IIT Kanpur and other IITs also, but this lab is unique. Now, I would like to tell you about my research group, which is Structural Dynamics and Uncertainties Research Group, and the acronym says Student RG. So it is good because I do not consider myself as an expert. I consider myself as a student of structural dynamics and uncertainties, and my entire life I am going to dedicate to study the structural dynamics. So this is the lab where we have Mr. Tushar Goyal. He is working with me as a PhD student, and Mr. Shiva Pudi, who is working as master student with me in this research group. So Tushar, he is working on the air blast response of concrete gravity dams, which may be very important, specifically if you talk about the current geopolitical scenario, as well as in India, if you see the border regions. So there are so many rivers and Himalayan terrain is there where a lot of concrete dams are coming up. So now I hand over to Tushar to explain his work. So you can see his models.
So, can you just come around here? Okay, so what I have been trying to do is to find what will be the equivalent force that will act on the concrete gravity dam. Let's say there is a dam in some very disputed area like in Arunachal Pradesh, the Wang region, and this is the concrete gravity dam, which is supposed to be a large structure. Since the structure is very large, there is very large impact area. It can destroy a lot of life if it has been suspected to any impact or damage. So what I have been trying to do is, let's say there is a problem that there is an air explosion near the dam. So there will be some forces that will be acting on the structure. So now what I am trying to do is, there will be shock waves to the dam, there will be reflected pressure. So now what I have done is that, let's say there is a pressure on the structure, there will be vibrations. That vibration will also affect the reservoir water, and that reservoir water will also affect the dam. So there is a possibility that it may get damaged. So this is now my equivalent model. This is a mathematical model that I have prepared. I am converting into a series of SDOF system, and I am trying to calculate the response. So first I want to show this video. So let's say there is an explosion center at here. Now this explosion center is moving away from the dam, and how the center of force is moving on the structure. Now this center of force will be used to calculate the equivalent the response of the structure. So as you can see that if this detonation center is very far away from the structure, there will be almost equal force at the center of the structure only. So same goes for here. So these are some curves that I generated with how the height of burst is varying and how the normalized distance of detonation is varying, and where will be the center of force on the structure. So now this algorithm will be used to find such conditions, and same algorithm can be used for designing the structure to calculate the what should be the design load on the structure, and after that there will be there will be response calculation, and we'll see that how much measures we should take to avoid such damage to the dam. So that's all for now. But I'm yes.
So mostly your जो आपकी एनालिसिस है वो आपकी ग्रेविटी डैम के ऊपर ही है या इससे भी
अभी जो ये है, क्योंकि ग्रेविटी डैम जो है बहुत मैसिव स्ट्रक्चर होता है।
या
अभी हमने रिसेंटली विजिट भी करे थे कुछ डैम, तो उस केस में हमने ये देखा कि जैसे आर्क डैम है, आर्क डैम इज अ शेल टाइप स्ट्रक्चर, लेकिन उसका जो रिस्पॉन्स होगा वो बहुत वेरी करेगा एक ऐसे स्ट्रक्चर से जिसका खुद का मास बहुत ज्यादा है, क्योंकि जो हमारी स्टिफनेस होती है दैट इज रूट ऑफ के अपॉन एम। अगर मास बहुत ज्यादा स्ट्रक्चर का, तो उसका जो रिस्पॉन्स होगा, जो उसकी नेचुरल फ्रिक्वेंसी, वो बहुत डिफरेंट होगी रादर कि आर्क स्ट्रक्चर में हो। और आर्क स्ट्रक्चर की एक और खास बात है कि उसमें कर्वेचर होता है, तो कर्वेचर का एक अलग ही इम्पैक्ट पड़ता है जो उसके रिस्पॉन्स में, जो कि इस केस में नहीं होता, इसलिए कंक्रीट ग्रेविटी डैम है। और इसकी इंपॉर्टेंस इसलिए भी ज्यादा है बिकॉज नाउ करंटली इंडिया इज हैज issued a lot of run of the river projects that is mainly in the Arunachal Pradesh. You must have seen some reports, and then there are also dams in Himachal Pradesh, and there are very strategic important structures for the country, not just for the defense purposes but for the economic and for other industrialized purposes. So we are trying to get the best out of our research, that how it can impact not just our country, maybe the whole scientific community.
Okay, great.
Thank you, Tushar, for such a nice explanation, and I'm proud that he is doing a very nice work. And recently, we have submitted a project also, so we are waiting for the results. And now he's working on his first research paper, and soon he will come up with some simplified equations, very small equations, which will tell the practicing engineers how the dam is going to respond to such apocalyptic forces. Okay. So now we come to the second student, Shiva. He will explain his work. Let me introduce first Shiva. So he is working on one of the marvelous structures and one of the proud structures of the country, which is Atal Tunnel. Atal Tunnel is the world's single tube tunnel, and one of the largest single tube tunnel in the entire world. And we came up with this idea because this is a strategic structure, especially for Himachal, because it connects two remote parts of the Himachal, and so many army deployments also pass through that particular tunnel. It becomes very important to analyze its risk when it comes to different kinds of hazards that can damage the tunnel: earthquake, landslide, avalanche, or man-made explosions. Because it has a strategic importance, there can be explosions as well inside the tunnel, outside the tunnel, but anything, they have the probability, they have the capacity to deteriorate the tunnel function. And it becomes very important that if we know the risk, then we can also mitigate the risk. So he is working on developing a methodology with which he can calculate the risk in such multi-hazard scenarios for tunnel structures, not only for Atal tunnel, but even for other tunnels that are coming up in India, especially in the very critical regions. So his main focus is going to be on the blast load, because we work in the area of blast engineering, but at the same time he is also looking for other kinds of hazards, for example earthquake, landslide, avalanche. So now I hand over to Shiva and he will explain his work.
Sir, can you connect? No, sir. Just on this one. As already Shashank sir mentioned that thing, based for the mountain regions, we are mainly focusing on what are the threats which are possible in mountain regions, like avalanches, landslides, and vehicular explosions also possible. And as Shashank sir also mentioned, it's a strategic importance because the Ladakh is the region which will be closed for 6 months during winter seasons before the Atal tunnel starts. But after the Atal tunnel starts, so now the throat movement is there, so it's a strategically, and for the growth of the country it is useful. So uh, so we did some literature review on the tunnel failure case studies. We observed some blast explosions happened in the China. There is a tunnel. So, and some and vehicular explosions, as I mentioned. So some of the incidents happened in previous years in the tunnels. So some life also how can I say, sorry, some the failure of the structure and also the uh, life loss of life is also happened there. So
Now that we come to the risk methodology.
okay, sir. So basically, we are focusing on to develop a methodology which will tell the damage level and the risk, how much risk it is prone. Basically, considering all the threats, I studied the FEMA manual. There is a US federal thing. They developed a risk assessment for the urban tunnels. Those are metro tunnels. But when it comes to the mountain regions, the situations, the geological conditions will be different when it comes to the urban areas and mountain regions. So we are mainly focusing the which are the factors which will cause the threat to the our underground structures in the mountain regions. We only consider those factors and we are developing the methodology, that is a rapid visual screening. There is a as Shashank sir mentioned, we are considering different threats, so it is a integrated rapid visual screening process. So uh, so we also went to the Atal tunnel region and we observed what are the precautions they taken for to mitigate the avalanches and different landslides, how to protect the structures. Here we observed some nets to reduce the flow of avalanche, and this is the portal, north portal of the Atal tunnel, and here some cut and cover method is happening, and beyond this there is a rock bolting is there. So to rock bolts are mainly used to stabilize the ground, so it will help to reduce the possibility of the landslides. So and these are the some walls, this wall is known as a buffet walls. These are mainly useful to avoid the avalanches. These buffet walls are mainly used instead of the RC walls, because RC walls are little more expensive than these buffet walls. Buffet walls are mainly constructed whichever the material which will available at the site, they will use that material, and they will use some nets to stabilize that thing. So uh, based on this, we don't know threats how it will happen, when it will happen, so there is a uncertainty is there. So to calculate the uncertainty, there is a process, fuzzy process. It will help to find the uncertainty. So mainly our process is using fuzzy logic, which will I show approach risk scoring. So we are using fuzzy logic, and here we will consider the whatever the parameters which are used in the risk scoring, and we will assign the uncertainty level, and finally it will produce one damage score, that is risk score. So and I also compared some tunnels which already uh, there is a earthquake, Wenchun earthquake, it happened in China. So these tunnels they did for a seismic assessment. So we developed our approach, and their damage levels, our damage levels, we checked for uh, uh, whether our results are validating or not. We checked for that, and it's validating, and some damage deviation is coming, we are working on that. And
Okay.
thank you for
सर कैन यू टेल मी दैट अभी आपने बताया कि गेट स्कोर के बारे में अभी आपने मेंशन किया था
हाँ
कि अब स्कोर Okay, okay. Just
Sorry for
okay, sir. So just you mentioned about the score that
Huh.
I just saw that some input is there and their fuzzies rule. After that, you have a score.
Yes, I will show.
Yeah, like
This
this.
one.
So this risk source score is there.
Huh.
So is there any numbers like in between this 1 to 10 or
We are taking 0 to 5.
0 to 5?
In fuzzy logic, we considered 5 damage levels. 1 to 5.
1 to 5.
Uh,
Five.
5 is maximum,
Okay,
high level,
five
very
is
high.
maximum high
Uh,
level. Okay, okay, sir.
so based on the coming damage index, and we will also uh, tell them what are the mitigations they are available in,
Okay, okay,
to
okay.
reduce the risk.
Okay, okay. So just you are identifying the damage level and
Yes.
you give the 1 to 5.
Huh.
Okay, then what after that? If you let us suppose there is a damage level is 5,
Yeah.
then there is a risk structure can be damaged or not. Like, is
Yes.
there a risk?
If for any risk, there are some parameters which are uh, posing that risk. For landslide, the slope thing is maintained, and to reduce the landslides, we will counter some mitigate structures. There, I will show one thing. We observed that. Recently, this is a Ramban tunnel which is in Jammu. Recently landslide happened. Here in that report we studied, they constructed the portal at toe end of that hill. So there are for at toe end parts there is the more possibility of the slope failures. As the professor from Delhi they mentioned that thing. So these factors we will say for the coming tunnel constructions we will mention, if we construct the portal at these locations it will be dangerous. So the tunnel alignment, those things it will be changed
Changed.
later.
Okay, okay,
Some type of mitigations we
okay,
will
okay.
give
So
them.
that means if any structure get a value of damage level 5, then it has to be changed.
It will
Or what
change.
if it has 4 or 3? Then no need to change. We can
No,
just
We can take some measures.
we can take
Suppose,
some
for
measures. We
example,
can.
if it is coming out to be 5, it means, for example, if it is coming out to be 5, it means there are some serious issues in that structure based on our risk assessment methodology, and then you need some kind of corrective measures which can reduce the risk.
yeah.
Or because how this risk scoring is done, this risk scoring is done based on several questions. So he has prepared some 60 around
60
questions for which the data is collected using the rapid visual screening and interviewing the engineers at the site. Based on that we came to know, okay, these are the problems in the structure, and if we want to reduce the score, so of course we need to reduce the individual scoring of those questions, and that can be done only by doing some corrective measures. So of course 5 is the highest risk and 0 is the lowest risk, and if there is something in between, so we can see, we can check whether those kind of, suppose there is a risk, then after that risk there also comes, suppose if failure happens, what will happen, what will be the consequences, are those consequences going to be very severe, or can, or suppose there are funds which are released by the government time to time for maintenance of the tunnel structure. So at the time of maintenance you can use that risk scoring approach to utilize those funds very carefully and effectively.
Okay, okay, sir. So one more question, sir. कि
Sorry.
सर जैसे अभी आपने डैमेज लेवल 2 के बारे में 3 आ जाता है, सो जस्ट वी आर आइडेंटिफाइंग कि ओके ये भी एक इसमें ये प्रॉब्लम भी हो सकती है, ये प्रॉब्लम भी हो सकती है, जस्ट वी आर आइडेंटिफाइंग व्हाट आर द प्रॉब्लम्स.
Yes.
And on what parameters you are saying that this damage level 3 or damage
Yes,
level 2?
exactly. So right now I just told कि जो questions हैं, तो इन्होंने कुछ 60 के अराउंड क्वेश्चंस इकट्ठे किए हुए हैं. वो क्वेश्चंस हम लोग जाकर के साइट पे ऑब्जर्व किए, उनके आंसर्स ऑब्जर्व किए, फिर हर क्वेश्चन में हमने इंडिविजुअल ग्रेडिंग की. फॉर एग्जांपल यू कैन टेल अ फ्यू क्वेश्चंस. Just tell a few.
I will tell some questions like tunnel thickness is also plays a major role, and overburden depth. Some tunnels are very less overburden depth at portal locations. Those are more vulnerable because as we did the literature review, we observed where the the overburden depth below 50 meters, the portals are highly vulnerable for the seismic thing. So if we observe those things, and the tunnel thickness at that locations it will be more, then it will be the moment of inertia, those things will help to resistance those things. Like each question have the priority, and based on the which threat is more prone there, those threat related questions they will observe firstly.
So for each question there is an individual scoring, and then we combine all those scoring
Yeah.
using the fuzzy logic approach.
ओके सो बेसिकली जितने भी जो भी अभी ये टनल पे काम कर रहे हैं, सो आप हाउ मेनी टनल्स यू हैव सीन या
Yeah,
गो थ्रू?
for field visit we went to Atal Tunnel only.
Okay.
But for the case studies I have done literature review. Majorly tunnels failures case studies are observed from China, maximum things, and some blast related one Moscow tunnel, there is incident, blast incident is happened in train, so bomb attack. So some blast related questions also we taken from literature review only, we haven't done
So
visits.
individually we are we from the literature which is the global literature, हम लोगों ने ग्लोबल लिटरेचर को यूज करते हुए टनल के लिए क्या क्या नुकसान कारक हो सकता है वो सब इकट्ठा किया, उसको एनालाइज किया, उसे क्वेश्चनेयर प्रिपेयर किया। वो क्वेश्चनेयर प्रिपेयर करने के बाद हमने अटल टनल पे उसको अप्लाई कर रहे हैं, अटल टनल पे अप्लाई करके अटल टनल का रिस्क स्कोरिंग निकालना है। अब इस पूरे प्रोसेस में जो हम लोग नया कर रहे हैं वो ये है कि अभी तक किसी ने भी टनल को लेकर के, स्पेशली हिमालयन माउंटेनियस टनल को लेकर के भी रिस्क अप्रोच मेथोडोलॉजी डेवलप नहीं की है। और खास तौर से अभी तक जितने भी रिस्क स्कोर हैं वो टनल के डैमेज होने के बाद उनसे उनका क्यों डैमेज हुए उसको एक्सप्लेन करने के लिए एक रिस्क स्कोरिंग की गई है अभी तक के लिटरेचर में। दिस इज द फर्स्ट टाइम वी आर डूइंग इट द प्री असेसमेंट यूजिंग द फजी लॉजिक अप्रोच, जिसमें हम अनसर्टेनिटीज को भी अकाउंट में ले रहे हैं।
सो सर माय लास्ट क्वेश्चन इज, जो ये फजी लॉजिकल अप्रोच है आपकी, ये सिर्फ टनल से रिलेटेड है और एनी काइंड ऑफ स्ट्रक्चर?
सो ये फजी लॉजिक अप्रोच अभी तक बिल्डिंग्स में बहुत लगाया जा चुका है, बट टनल में हम लोग आई थिंक वी आर ट्राइंग इट,
but post assessment they use it fuzzy logic. But for pre
assessment we are doing it first time. So जो अटल टनल का हम इवेल्युएशन कर रहे हैं, ऑल ओवर वर्ल्ड जितनी भी टनल्स में फेलियर ऑब्जर्व किया गया है उससे हम लोग नॉलेज गेन करके क्वेश्चनर बना करके फिर हम अटल टनल का प्री असेसमेंट कर रहे हैं।
ठीक है, ग्रेट सर।
better late than sorry.
So preventive health checkup.
Yeah, great sir, great. So thank you Shashank sir.
Thank you.
आपका अभी
and thanks to the team of YourPedia for this initiative.
थैंक यू सर, थैंक यू। बाकी सर जो ये आपकी लैब है वो
जी,
तो वहाँ पे मोस्टली बीटेक के स्टूडेंट्स के लिए
that is only for the undergraduate students.
ओके, ठीक है सर, थैंक यू सर। ओके।